I was browsing YouTube to send a different, a video from another instructor or another student to give some perspective, because sometimes we just need to hear these things from somebody else, because their interpretation and their words just kind of unlocks the understanding. But I was browsing YouTube and I came across this picture and I thought this is pretty good. The disc method is where you're finding a bunch of these circles, a two-dimensional measurement, a two-dimensional shape, right? Circles, and then you integrate it. This time it would be along the x-axis to change it from 2D to 3D. Right, so that's the disk method or the washer method. The shell, I think the washer method would just be the disk method twice, right, where you subtract the bigger outer circle by the inner circle. The shell method is where you're actually constructing a bunch of right cylinders, but we're finding the surface area of each of those cylinders. And then that surface area is 2 dimensions, right? So the shell method works because you take a 2-dimensional measurement, surface area, and then you integrate it, which brings it into the 3rd dimension. That helps us calculate volume. Okay, and then here's the formula. If you're using the shell method, revolving around the x-axis, then we integrate with respect to y, and then vice versa if you're revolving around the y-axis. The first thing we need is to know what area we're trying to find. So we have y equals 2x, maybe a little steeper. We have x equals 0, which is just the y-axis, vertical line, and then y equals 2. And it's always helpful to know these points of intersection. So where do these two curves cross? Well, you can always find out where two things cross in math by plugging one into the other. So 2 equals 2x, you can solve for x and you get x equals 1. So that's where they cross. Okay, so we want this volume, and we want this 2-dimensional area revolved around the x-axis to create that volume. So let's draw a right cylinder. Let's see. Oh, and this is a good one too because this is already showing revolving around the x-axis. So when we draw a right cylinder for this area, so one shell of the infinite shells we're going to be creating look like this. And then we'd find the surface area of that shell. Oops. And then another shell, going a little bit further along the curve, and end up right here. There's our right cylinder. We'd find the surface area of that shell. And then we have another right cylinder as we go further along. So for each of these shells that we're finding the surface area of, the radius is this. This should probably go a little further because the radius should be halfway through. But the radius is the distance from the x-axis wherever we've drawn that shell. So like for this last one, this would be our radius, right? And then for the first ones I drew, it was a little more narrow. This would be our radius. So the radius is the y distance, the distance we are on the y-axis. So the radius of each of these shells is y. And then the height of each of these, that depends on how far along we are on the x-axis. So once we get to this point on our curve, we're this distance on the x-axis. So that distance is defined by this y equals 2x line. If we want to have everything in terms of y, right? Because when we integrate, going from 0 to 2 on the y-axis, we're integrating the formula for the surface area of the right cylinder. The surface area of the right cylinder is the circumference, 2 pi r, times the height of the right cylinder. But in this case, r, the radius, we just said is y, and the height also needs to be in terms of y, so we just have to rearrange this equation a little bit. So the height is y over 2, and then that's with respect to y. Okay. And so that's everything we need. We can simplify a little bit. 2 times something over 2 cancels. The rest of this is just straightforward integration. That's y squared, so the antiderivative would be y to the 3rd over 3. And if you plug in those limits of integration, you're going to get 8 over 3 minus 0 over 3. So 8 pi over 3 should be the volume. Okay, but I think that visualization is the most important thing. Half the students, they get disk method and they're really comfortable with it. They have a hard time with shell. The other half, they like the shell method. It makes sense in their head. The disk method doesn't make sense. So maybe comparing them with that little thumbnail I found on YouTube will help. Okay, but the shell method, you're creating those right cylinders, an infinite amount of them, and you're finding their surface area. And then we turn that 2D surface area into volume by integration, because the antiderivative would bring us from the second to the third dimension in measurements.